Hello and good morning or good afternoon, wherever you are. My name is Eva and I am Operations Manager at ThisDot, and I wanted to welcome you to GraphQL Fireside Chats. It is co-hosted today by myself from ThisDot Media and Tanmai from Hatsura, and we're going to have a conversation today about it. Sponsors today are ThisDot Labs and Hatsura. We've got a couple more upcoming ones let's see, the next one's going to be on April 28th at 9 a.m. Pacific time and 12 p.m. Eastern time. And then another one on May 12th. And then we have GraphQL Meetup for more information on it. Today we've got Tanmai and John and Mark, and they're going to have a lovely conversation about GraphQL. It's going to be very exciting. So stay tuned, and I will turn it over to you all. Just a minute. Let me get out of presentation mode. All right, take it away.
All right. Hey, everyone. Hope you all are doing safe and keeping sane. Very happy to be here today and very happy to have John and Mark with me. We'll be chatting about performance and monitoring and performance monitoring, like all permutations and combinations that you can do with those two words with GraphQL. And so before we get started, maybe a quick round of intros. Mark, would you like to go first?
Yeah. Hey, my name is Mark Stewart. I'm a senior manager at PayPal. I work on PayPal checkout integrations and SDKs. So if you've ever integrated PayPal into your website or mobile app, that's our team. We started using GraphQL a couple of years ago in checkout, and it was super successful. And then it completely exploded at our company, and a bunch of teams are using it. Totally looking forward to having a good conversation with you both about performance and monitoring. I know that's something we've ran into some issues and kind of overcome those. So, yep, glad to be here.
Awesome. John?
Hi, my name is John Wong. I'm a staff software engineer at Coursera. It was actually really good to see my pre-quarantine haircut at the beginning of the slides there. I can see everyone's getting a little long. Time I was just cutting his own hair. So I work on the developer experience team at Coursera. Coursera is a internet, basically higher education online, lots of courses for free, really great opportunities right now. And on the developer experience team, we do everything we can to help make sure that developers can build and ship code quickly and safely. We've been using GraphQL for about 4 years, pretty early on in GraphQL's iteration. And recently we've been working on a new GraphQL stack at Coursera.
Got it. Before we get started, most important question, how did you get the haircut during your quarantine times, John?
I didn't. This is at a certain point. So my hair grows this way, and then it gets so long that gravity is just pulling it down. So now it looks like it's reasonable, but it's the ears.
And so what was the GraphQL stack before like, and what have you moved to now at Coursera?
Yeah, so we started off using a really, really great GraphQL server built in Scala. Scala is one of our backend languages of choice. Java is our new language of choice now too. We used it. It's called Sangria, really, really solid library. And we used that really early on. It was interesting. We used it in a particularly novel way at the time, which was we took our REST APIs and we would generate GraphQL schemas from those REST APIs. So you can imagine the entire API surface, 1,200 APIs or something like that. All available at once in GraphQL. The new stack that we have now is a little bit more, I would say, curated. So instead of exposing everything in the world, we're very selective about what we expose. And in return, what we get is a much more well-designed API, because the APIs are based on the product use cases, not based on what the APIs were exposing in the past.
Right. And so is the client side, did the clients fully migrate to the older GraphQL API and now they're kind of bringing in the new GraphQL API? Is that what it's like? Or do the clients still have a little bit of REST and GraphQL mixed in?
It's definitely a mix. And I think that's one of the downsides of having the GraphQL schema match the REST API, is that you could use them interchangeably. So it was really like, okay, did you want to use this GraphQL tooling to hit the same endpoints?
Right.
Whereas in our new stack, what we're touting is essentially it's a much better designed API. So you'll want to use that and not the REST equivalent. Yeah.
Got it. And what is the new stack? What is the new tech stack? It's not using Sangria anymore?
No, we're not using Sangria anymore for a couple of reasons. One is, again, like I mentioned, we're moving to we're trying to use more Java in our stack. We are currently building that GraphQL stack in TypeScript. Lots of really great tooling in the JavaScript ecosystem. We wanted to be able to take advantage of things like Apollo, that sort of stuff. So it's been nice to have it be in a language that's closer to front end. Definitely navigating some language barriers, but I think it's been an interesting choice so far.
Got it. What's the GraphQL stack at PayPal checkout like, Mark?
Yeah, so PayPal GraphQL is used really at the edge of our stack near our web and mobile experiences. I'd say similar to John's case at Coursera, our GraphQL schema is really built around products, not internal domains or database schemas or anything like that. It's built by the product developers. They're the ones contributing to it. So, all of our web experiences are built in Node and JavaScript. So yeah, naturally our GraphQL APIs are built in Node. But we do have Java support now. That kind of came a little later. Really, it was kind of the UI developers that were super excited about GraphQL. So that's where it started. But now kind of your more traditional backend Java engineer is interested. So we'll see what happens there. Who knows if it'll kind of start from the edge and kind of grow into other parts of the stack. I'm not sure.
Got it. And in both of these cases, if I understood right, the GraphQL is still delegating to the REST API. So the REST APIs are still the same. The backend developers are still doing the same thing on the REST API side. But the GraphQL layer is kind of maintained by the product teams, which is delegating to REST. Is that correct?
Yep, that's correct. Yeah, it's similar to Coursera. We have like a ton of REST services, and those were built up over probably the last 8-10 years. And so there's no way we're gonna change everything to GraphQL. I think REST is actually a really good building block. I think REST makes a heck of a lot of sense right next to the database.
Right.
It's where you can kind of build your core services. But I think GraphQL is really how clients, kind of web and mobile apps should talk to those APIs.
Yeah, more like a kind of like the modern backend for front end kind of use case, right? Like a better backend for front end kind of use case.
Yep.
Got it. And it's very interesting that there was so much success with GraphQL for the checkout use case, because it sounds really like transaction heavy, right? It sounds like there'll be a lot more mutations than queries, whereas like a lot of the bread and butter success and ROI of GraphQL is usually around the querying capability, right? Like the fact that I can query so many things at the same time, right? With mutations, it's kind of harder to understand really what the benefit of GraphQL sometimes is, right? Because you're just like, well, I'm calling a REST endpoint and I'm calling a GraphQL mutation. How has that experience been?
Yeah, well, I think we saw really big gains on the performance side and developer experience, because we went kind of, we started from the other side. We were completely all about REST, and so if you're all into REST, that really usually means a lot of round trips from the client and server. And so, yeah, you're right. Checkout is very transactional, but there's often a lot of steps. Like if I'm a guest checking out in PayPal, we need to create an account. We need to add a credit card to it. We need to kind of like vet all of those credit cards, make sure they're all like, there's nothing risky going on with the transaction. Then we need to make the payment. So usually we're talking about 4 or 5 round trips from the client, whereas we swapped it out for GraphQL and had really good performance gains because we cut out all that round trip. So I think for us it was super successful because we were on the other side of the spectrum, just no orchestration going on, just tons of REST everywhere. So we saw some really big gains in checkout.
Got it. And what was the like before this, you just had a bunch of disparate REST endpoints, or was it already going through some kind of a API gateway, like BFF kind of layer, or what was that earlier REST API gateway like that the clients used to hit? Were the clients aware of all of these different endpoints, or was there kind of like this generic endpoint and like there was like sub path, like path based routing or something like that?
Yeah, no, not really. Yeah, it was just a ton of different services. It's very common for a product team to talk to 15, 20 different services to get the data it needs, and they need to be aware of all the different endpoints, all the different parameters, all that, and it's not fun at all. So really, GraphQL brought really nice developer experience there too, because they could just ask for the fields and types they need. Right.
Got it. And so if I'm right, like from just tracing the request response, right? It's like client probably goes to something like a load balancer, and then based on the kind of domain path or whatever, it gets routed to the right service. And now that's changed to client goes to load balancer or whatever, and then that hits the GraphQL service. Mm-hmm. And then the GraphQL service then delegates to one or more of these microservices.
So that's correct. And you might be thinking, oh, that's an extra hop, isn't that slow? But not really. I was talking about
N+1 on the client. It seems like N+1 on the server is better than N+1 on the client.
Exactly.
Right? So,
yeah, you're talking about like a couple milliseconds, between server to server in the same data center. Whereas it's hundreds from the client server. So
got it. Interesting. And I'm sorry that I missed that. Like, what is the language that GraphQL Gateway is kind of written in?
Node.js.
In Node.js. Got it. And so, what have been the like big performance challenges and that you saw as you switched over from that collection of like different REST endpoints towards the GraphQL Gateway, Mark? Like, what was that like? What are the biggest challenges that you saw? And like maybe my kind of way of asking this question is like, what was the biggest outage, and what's been the most frequent recurring issue, or what used to be the most frequent recurring issue, right?
Yeah. Well, I have a few notes written down here, so I'm going to talk for a few minutes. But I'd say the most common issue is repeated requests to the same internal API. So you might have one GraphQL query where in order to resolve a type or a field, you need to hit that same internal API. And so, really, we found out early on, like in checkout, if you request a user's funding options or credit cards, that runs through all kinds of risk and fraud checks. That's like PayPal's big value prop. So, really, we found out that we were hitting that service like a lot. And then that actually caused a lot of risk declines, a lot of drop off for checkout. So for those few users that we were A/B testing this on early on, like they were probably really frustrated that day.
That's really interesting. So basically, if I have that right, it's basically because the kind of parameters for fraud detection are based on the number of REST API calls that were happening, and that kind of stack remained the same. Because of adding GraphQL, the number of REST API calls kind of increased.
I think there was an assumption built in there, probably from a really long time ago, where it's like, they probably thought where like, hey, if this checkout experience is being hammered by some bot or something like that, just like requested say 20 times in 10 seconds, like something's off, maybe let's flag it and deny it or something. So they probably added some kind of check from a really long time ago. I'm not really sure how the risk rules work, but anyways, we ran into that really early, and we're like, oh crap, we really need to dedupe all of these, internal API requests. So, a really common way in Node.js is to keep a cache or memoize promises. And so, once we did that, everything was kind of back to normal. But yeah, actually, we run into this a lot. A bunch of teams will be super excited about GraphQL. We'll try to get in production as fast as possible, and run into this issue. And you can kind of put docs out there and a bunch of training, but it's people are super excited. They just want to try this out, and they'll run into that challenge later usually.
Got it. Did you face similar challenges, John, with the REST API adoption? Did you have similar issues?
Oh yeah, definitely. I think the fan out and deduping was like one of. I mean, it's not something that's enabled by default. Obviously, it's not. It's more of an implementation detail than anything.
Right.
But that was one of our bigger outages with the new stack too. Was we were just hammering an internal API with. It's so easy to do it because of the way resolvers work in GraphQL, because you're just hitting the same things over and over again. One way that we designed out of it that was useful was that we basically attempt to have our resolvers do as little as possible. So basically, they feed right into another abstraction, which is a data source or a data loader that does that caching right out of the box, so that you just can't do anything without having proper caching. But I think that there are some downsides when you have things that don't cache well. User-specific stuff tends to be hard to cache. So, but yeah, that's one of the things that hit us really hard. It hits us, all the time. That's the thing that we need to keep fixing.
Got it. And if I'm right, this what you both are talking about is kind of on the query side, right? Not on the mutation side. Like, we're not talking about like the mutation having a mutation ID that you use to dedupe the mutation and then pass that along to the REST API. We're not talking about any of that. We're talking about like queries and repeated REST calls for queries. Yeah,
I think the design pattern around resolvers is a little bit of a different mental model for retrieving data, because every resolver is intended to be independent. So you design them independently, but that means that for every field on an object, if you do it wrong, you're going to hit times n number of fields. Whereas in a normal, I don't know, not normal, but like maybe your typical REST API development, you just get the blob and then do property access off of it or something like that. So it's a different mental model, and I think people still have to get used to it.
Yeah, makes sense. And so, Mark, how did you discover that problem at the time? Did you do a round of benchmarking with different API endpoints, or did like things suddenly just start going wrong in production? And then you were like, "What's happening? What endpoint is this? What resolver is calling what? What GraphQL queries?" How was that?
Yeah, so for us, like, we knew that, hey, like, risk declines went up a ton, and all these people are getting denied, like checkout. And so, yeah, for us, we really didn't use any performance tool for that. It was just, we asked the risk team, and they're like, hey, you're calling us like tens of times. What's going on? And so, we kind of quickly knew that, hey, this will grow into an issue if we don't start, keeping a cache of these promises.
Right.
So, yeah.
Got it. And based off that experience, like, if you were building something today, how does that roll up into some kind of tooling or best practices, or the way you would think about just building that kind of GraphQL gateway that maps to REST APIs, so that you don't trigger these kind of almost non-functional things that happen on the background for REST APIs, right? That you don't expect to hit when you're calling the REST API, and not to kind of trigger bad behavior for your upstream services. Has that evolved into some kind of heuristics that you follow now, or some kind of like the way you write things, or the way you put in tooling or something?
Yeah, so we were a little late to the game with kind of like production ready tooling, and kind of like John was saying, maybe put your cache at your data sources or data loader layer. We were a little late to the game because a ton of teams are super excited, and at PayPal, product teams are just super autonomous, and they can really do whatever they want. And so yeah, we were catching up. But yeah, nowadays we definitely have patterns for that. Now it's just kind of grabbing those early adopters and getting them to, hey, like, use this library, please.
Got it. Makes sense. And just to kind of note a nuance here, you're talking about memoizing like within the life cycle of the same GraphQL query, right, Mark? Whereas John, I think what you also talking about both that kind of memoizing / data loading kind of thing, but you're also talking about caching the data responses as well in some cases. Is that correct? Like across different GraphQL queries?
I think the more important. Yeah, I think the more important one is definitely the in requests caching. For like, that one had the more dramatic impact for us. Across request caching also has its own bag of worms, because of cache keys can start exploding when you have so many resources.
Yeah, that makes sense. So just to kind of help me understand this more clearly, could you describe a GraphQL query where the exact same REST API endpoint is being hit with the exact same parameters? Is that kind of the issue, or is the issue that you're hitting the same upstream service with different parameters, but you're just making like multiple API calls to the REST API with like, you're making REST API call like $, param 1, param 2, param 3. What is the specific issue here? Or is it both? Mark?
For me,
sorry.
Oh, go ahead. It's more of the former, I think. When you're hitting the same API with the same parameters, you can cache the response and you can operate on it. But again, if you do this, if you follow the pattern of making resolvers independent in GraphQL, which is sort of like how the resolvers are designed, but you don't think about the caching part of it.
Right.
You'll immediately get, a bunch of requests to the same endpoint for the same information. And I think that's the part that got us stuck. But what was hard about it was that it only showed up sometimes.
Yeah.
And that's because, for example, if we had an enterprise, this was our example, is we had an enterprise that had 10 admins. And it was like, oh, performance is fine. Then the enterprise that came in with 200 admins and 1,000 admins came in and then blew everything up, right? So it was one of those things where if we had looked at the pagination and looked at the limits, we would know that, hey, this could possibly get hit by 1,000 folks at once. Like we need to make sure that we're not hitting the same API 1,000 times. Got it.
And so did you, to kind of the same question that I asked, excuse me, Mark, right? Like, do you also have now tooling in place? Like, how did you detect those issues, John? Like, did you see them pop up because of you saw specific GraphQL queries and pages slow down for specific users, or did you have some kind of tooling in place to help you detect that?
Yeah, I think one thing that's really nice about GraphQL is because we get a visibility into the entire query. So the different pieces stitched together. What we found was we were tracking the query performance for a specific query. In this case, the query that powered a particular page. And then I was able to see, hey, like the P95 for this is like 4 seconds, which is absurd. And basically said, hey, why is it doing this? In this case, Apollo had all this tooling already built in. I had a report that said, hey, P95 is high. I looked at it, it said for this particular operation with this set of variables, like it's really high. And it's like, oh, why is that? Went, reproduced it myself and said, okay, yeah, there's 1,000 admins here. So that's why it's getting hit so much. So that really helped us figure it out, because in our testing use cases, I just didn't even think about that use case.
Got it. And has Mark, has the question that I had about like the REST APIs that were being hit with different params or the same params, was it the same params kind of use case for you as well?
Yeah. Same params use case. I think for us, the problem was really amplified because we're using, our front end's written in React and we're using Apollo client, and kind of a best practice there is to, have a bunch of little small queries in your page, usually per component even. And, by default, all of those are batched up into the same request. And so, a lot of those components might depend on the same state from some entity or something like that. And so, when your server goes and resolves all of those individual little queries, you might hit the exact same API with the same params. And so, the problem was really amplified because, it's really a best practice to chunk up those queries, either into fragments or individual queries.
Right. Makes sense. And what were kind of the other outages? Any other notable outages that you had at PayPal, Mark?
Yeah, I have a few. There's so this is pretty specific, but it's like between Apollo Server 1 and 2, they the pattern was changed from like an express middleware type pattern to like an entire Apollo Server instance that you knew up. You might know where I'm going with this, but we weren't very careful, and we were newing up an entire Apollo Server instance on every request. And we were like, what is going on? Like the event loop is stalled for 100, 200 milliseconds per request. It was pretty quick. It was like, within a couple of hours after we released this to prod, we were like, wow, things are like way slower. Come to find out that, whenever you new up a new instance, we found that your entire schema is hashed, and that's a synchronous operation in Node. So the event loop was just blocked. It was really bad, but pretty much we fired up InSolid. InSolid's a really nice profiling tool for Node.js, and it was completely obvious what was going on. We fixed it and rolled out. But I'd say that was probably the biggest kind of perf issue that we found with the profiling tool. But there's a few other issues I could mention too.
What about you, John?
How do you spell that tool name that you just said?
It's called N solid. I guess if you're going to Google it, it's like N, the pipe character, and then solid.
Got it.
Yep.
That might be useful.
Yep.
I assume, yeah, you. Go ahead.
Sorry, but I'm guessing like what you're kind of basically saying is that any kind of like profiling tool that's specifically available for Node.js would have given you kind of that event loop insight, right? Like whether it was New Relic or Datadog or whatever kind of like language specific or profiling tool that you would have told you that the event loop is slower. You know, this time is being spent in this function and stuff like that. Got it. Makes sense. Yeah. Sorry, John. Tell us stories of downtime.
Yeah, our biggest outages actually come from it's less about the resolution. I mean, we do get some of those resolution things.
Right.
They tend to be reasonable that we can map. We have some heuristics where, for example, we force all of our REST resources that are in GraphQL to expose multi-gets. So you cannot call, like we'll never delegate a single get call. We'll only ever delegate batches to those endpoints, and that facilitates the GraphQL things. That wasn't due to an outage. That was more like a design decision. But one of the things that we've had trouble with is because our GraphQL, it's a gateway, and the gateway is proxying to underlying services. There's yet another sort of interaction with these underlying services that gets a little bit hairy. So for example, if the API of that service, that REST service, has a breaking change, things get really hairy because you can't really like map over it well in GraphQL. And because of the way that we auto-generate things, it gets a little bit nasty. We've had issues with, for example, routing requests to the right services when we have to switch the resolution of a field from one thing to another thing. That has introduced a lot of issues. So it's more like, if we think of GraphQL gateways as glorified routers, then these are routing issues that we hit, and there's not a really good pattern or a strategy for doing that other than being really careful. Got it.
And did these did these result in changes that you enforced on the authors of the upstream services, or did you handle this mostly by fixing stuff at your end on the GraphQL gateway? Like the multi-get is kind of one thing that you enforced on the upstream services to say, please add multi-get. And I guess that would have been a trivial change for them because like the framework itself would have allowed you to just expose the multi-get option, right? They wouldn't have actually had to do anything like too much. They wouldn't have had to change anything functionally. But have you had instances where you've had to ask the upstream authors to kind of change the way they work a little bit to make it easier for you on the GraphQL gateway, John?
Yeah, that's a good question. Yeah, the multi-gets, we basically say your service is not going to get exposed into the gateway if it doesn't have a multi-get, if it doesn't have certain parameters. So there's certainly some selections that are there. We definitely, as opposed to maybe a more typical GraphQL gateway, we expose the relations in the services themselves. So we sort of federate their connections to other services. Right. I think the thing around mapping fields, I mean, we haven't found a good way of like making it a heuristic to make it easier to switch the resolution of fields. In our new stack, what we do is, the thing is that it's hard to differentiate choices that were made in the REST world from the ones that are in GraphQL. So in REST world, we basically we don't tolerate breaking changes at the REST API level, and instead enforce people to version. So when they version bump, then the GraphQL schema now exposes the new versions thing. And so clients have to switch using the new version. So we version it using the REST versioning schemes that propagate through GraphQL. So I think that's probably the as a result of REST rather than GraphQL itself.
Got it. What about you, Mark? Did you notice like changes to the upstream services because of the GraphQL gateway that kind of came in?
Not really. We really tried to just work with whatever we could and just make it work. But I do want to say that GraphQL really did kind of force changes on our node framework. So with GraphQL, you often have a fan out of a lot of calls to internal services, and we found that our HTTP client that we have internally, it actually had a lot of TLS overhead in Node.js, which Node's really bad at SSL and TLS, super slow. And we found that we were creating a new SSL session per request for every service call, which really was blocking the event loop and really decreased the throughput that we could get. So GraphQL kind of forced the issue a bit. It was like, hey, no, let's fix our HTTP client. Let's cache these SSL sessions, with maybe like a few minute TTL, and really it kind of improved our whole Node framework. But for upstream services, not really. I don't think GraphQL really forced them to change much, but it did their frameworks.
And for in both of the use cases, like in both of the cases that you're talking about, right? Is it kind of like the I imagine that there was some kind of performance and monitoring tooling that like performance monitoring or just generally health monitoring tooling that the REST API folks had, right? Has that largely remained the same, or has that changed because of the introduction of the GraphQL Gateway, right? For example, let's say there was tooling that was dependent on some property of the client, right? Maybe it was like based on user agent or like the IP that they're coming from, or you had some analytics that was coming in because of the client querying, like introducing that proxy in the middle. Has that not forced those upstream changes on like those kind of things that depends very specifically on the client? Has that happened at all?
Yeah, I could go first. Really our big issue that we were facing was, in GraphQL, everything's supposed to be, HTTP 200. And we have all of this internal tooling built around REST and inspecting that status code. And so, a service can appear to have like 100% availability, but it's like, no, like, your GraphQL API still is throwing errors. It's just, the tooling doesn't reflect it. And so, yeah, we did have issues there. We had to go back to the SRE and ops team and get them to look at something else. I think inspecting the GraphQL response and looking for that errors array is maybe out of the question, just because there's a lot of overhead in that. But we did introduce another type of a status code called it has to do with our internal logger, but another type of status code besides HTTP, which kind of reflects the errors or the response's severity. So we kind of changed their tooling to look at that rather than HTTP because we had the 200 in order for any GraphQL tools to really work well. So
that's very interesting. I've encountered like similar issues where I think like generally nobody logs the response. Like logging the response is considered is kind of like a higher security privilege, right? Because usually you never log the raw request or the raw response, or like even if you log the raw request, you make sure that you don't log the variables, right? You're logging the query, right? Not the actual variables that users are sending in, because generally what happens is those logs are sent out to some third-party system, and the kind of access that people have to view logs is very different from the kind of access that you need to have, especially for, I can imagine, like for PayPal like kind of transactions, right? And so I think that's like a very interesting point on like, how do you deal with the fact that the response, like the tooling that, all of the tooling that you have around the health or the status codes that are being used to do anything peripheral, all of that is going to break, because it's not just a matter of changing like the response code analysis to now parse the JSON body log. It's the fact that you have to talk about like a whole different kind of security across several teams and say, what, we're going to start logging responses now. And then everybody's kind of freaking out because they're like, wait, what? No, we don't log responses. That's an anti-pattern or whatever.
Yeah.
That's very interesting. And so in your case, Mark, if I understand correctly, you basically also would send out that data on HTTP state, on the HTTP headers. Is that in addition to the GraphQL header?
Yeah, so we would definitely log, like an overall HTTP status code. Like all services of PayPal like have to adhere to this like spec where it's like you log the HTTP status code, you log kind of the severity of your response. Is it successful, kind of a validation error, like user error, or like a fatal error? So all services are logging this. But yeah, you were talking about the actual response there, and you're totally right. You can't log that because you're dealing with credit cards and user information and PII. But what we did do is we logged the shape of it. So we would just mask out everything. But we would, rather than, so let's say like user's first name, it'd just be like a bunch of asterisks. And usually that's good enough for developers because, maybe a UI developer would say, hey, you didn't return this field to me, or it was missing. And then you could point to it and say, no, it's right here. We did return that first name string, right? It's just you can't see it.
Yeah.
Yep.
What about you, John? Have you also faced similar kinds of problems with the?
Yeah, I mean, definitely trying to figure out how to replay some of these. Like the way that I caught some of these errors was like I was looking at it and seeing, okay, users typically has 10 results and this one had 1,000 results, and it's like, okay, that's why it's taking so long. And Apollo has some nice visualizations there.
Right.
The traces help too. So looking at the request IDs and the tracing under the hood. So we use Zipkin under the hood for our REST services. So all of that's getting propagated, and seeing that entire waterfall and seeing, hey, there's a huge section where you're just spamming a particular service was really helpful. Mark, you bring up a really interesting point though around severity. One of the things that we've been thinking about is like, so how do you like reason about correctness of a particular GraphQL query? So say that it does return. Say that it does, let's say that we can't inspect the errors because, there could be a bunch of different errors. But like from a client perspective, since we don't have control over the schema, nullability is sort of, based on the design of the API. But the sort of query shape is hard to reason about. And I'll clarify. Basically, if you have the front page of your site or whatever, and you have the most important thing is at the top, and that's the piece that fails, you have a problem. But if some sort of leaf thing fails, then maybe you're okay. Is there, like, how have you dealt with, okay, this GraphQL query did return 200 and return the important information, and even though it failed on this other stuff, it's fine because our client handled it properly.
Yeah, I'd say that's definitely tricky. From a client's perspective, that batch of queries appears to be a 200, but yeah, we basically kind of dump that responsibility on the UI developer to inspect through the errors, and depending on the component that gets that error, is that component critical or is it just something that doesn't matter? They're kind of, it's their responsibility to figure out, hey, should I fall back to another experience? Should I throw up a fatal error? Should I just ignore it and just continue? Yeah, unfortunately, we kind of just dump that responsibility on the UI developer. Yeah, I mean, we're kind of talking about it, but errors in GraphQL are super tricky.
Yeah.
And I know that's really not the focus of this talk, but it's something where we're still looking at. It's like, is the errors array good enough? Should we use like a union, kind of like what is it, Medium, and maybe Twitter uses now. Yeah, we're not super satisfied. We're totally looking for a better way to do this.
So just to summarize, like right now you return partial responses. Is that correct? Like basically you resolve it partially, and then you have a partial response, and then whatever you can't respond for because of an upstream error or because of a whatever error, you return nulls inside the query, and then you put the rest in the errors extension array. And then the clients have to, the clients, depending on how the client side tooling is set up, right? If you have something like Relay, then in that case, you'd probably just get, in that case, John is just like, all of GraphQL Ramen last week, I was just like, relay. But basically, either your component will just get the null directly, or your component has to examine the response that you have and then see whether the error extension that you have is something that you want to worry about, right? Yeah, which kind of brings me to an interesting point. Like, how do you think about like health monitoring for your GraphQL service? Like, how do you even define health of your GraphQL service, right? How are you dealing with that, John?
I think that's what I was getting at as well, was like, yeah, like Mark said, our GraphQL server is like 100% uptime. It's always returning 200s, and it's great. It's perfect. But the thing is that, yeah, if there's any, infrastructure issues, if there's anything underlying the issue, or there's an upstream failure or anything like that, we can't really reason about that, even though that might actually be a responsibility of the gateway to handle that properly. When it comes to health monitoring, we've done it a couple ways. I mean, we think that there is, we've been doing the thing where we inspect the response. So we have some sort of preset queries where we'll make a query, make sure that it gets through the entire sort of work, integration, like end-to-end workflow, and returns us an actual object with no nulls in it, or for example, or equivalently having things that should fail, and then mapping that out. And we run that, every PR, we run that every push to master. We run these what we call health checks. We've also been doing slow queries. So queries that have given us outages before, we will take those same queries and we run it in the same suite. So we make sure that we're not regressing on queries that should not take us, longer than a certain amount of time, or that we know we've had issues with in the past.
We've been doing something very interesting around those lines as well, where basically the underlying unit that we have is something called captured queries, and we use captured queries to basically either like a regression suite during dev and staging. So we capture queries that happen during production, and then we replay them in dev and staging to kind of get a sense of like, that just kind of gives you schema validation errors. But if you have really good, if you have like a good if you have good mock data that's set up in your staging environment, then usually the same queries will also give you good diffs on data. So you'll see if there's like nulls appearing or data volumes changing drastically, right? Like something is supposed to return 10, it's returning 1,000, or something returns 10, it's returning 1, right? So there's a bunch of things that you can start layering on top of that. But it kind of does go into the fact that like a lot of the tooling changes to response analysis, which was usually not a thing during the rest times, right? You would never peek into the response, right? Usually. So it's interesting that it's kind of happening for that. In the kind of the monitoring tooling that you have, apart from what the REST backend folks used to use, how has that production journey been for you? Did you talk to the REST backend folks and then adopt a lot of like the similar tooling and integrate with that, or did you kind of just decide to use whatever you needed to use, and the upstream services they had their own tooling, and then you didn't mess with that? What was that part of the journey like? And especially because I think this is an interesting question for me, because it's kind of like the team that was kind of more responsible for the UI and the product is now taking up a quote unquote backend responsibility, right? And in light of that, like the choices and the kind of like the tooling that you have to integrate with might be a little bit different, right? From what like the backend folks would have done. So how has that played out?
Yeah, I could go ahead, John, if you want. So I was talking about this like other status code before that's not HTTP, and really that's all built around this logging platform from like, I don't know, it's so ancient. It's like 10, 12 years old. It's called Cal internally, but it's actually, although it's super old, it's really cool where it's like a request has this correlation ID, and every single service that it fans out to has this. And so you can very, very easily kind of like see a waterfall and trace. A lot of modern logging stacks have this nowadays, so we're swapping it out. But really, besides Cal, every single app or API that's created gets a default dashboard and like a lot of tooling for free. This internally, we have this internal thing called Sherlock, which is pretty nice, but it's geared around REST. So yeah, really we paid for Apollo Platform and Apollo Graph Manager, which is pretty good because you could see at a query level what's slow, what's problematic, and you could really focus there. I mean, it's something we could have built ourselves, but it's pure build versus buy thing. Like Apollo does this full time. They're very good at it. So.
Makes sense. And the tracing, like the tracing kind of aspect that you talked about, that needs to integrate with the upstream systems, that's something that you're manually wiring through. Like you ensure that every time there's a request, like is it based on the request ID? Like you have a request ID that comes in from the client. Yeah. Is it generated by the client, or is it auto-generated by who generates that request ID?
It's generated by like a kind of a reverse proxy that sits in front of everything. And so it generates it. Everybody kind of follows this contract.
Got it. And then you just pass that forward to the upstream service.
Yeah. So that's just part of our frameworks. It's nothing GraphQL specific, really. We tried to use kind of our logging and monitoring platforms like what we get for default, but it's just not good enough. You need something GraphQL specific that could peek in and see things at an operation or query level, because really that's what you're focused on. You're not focused on the overall batch or the whole HTTP request. You're just concerned with queries, really.
Yeah, makes sense. What is that like? What is that tooling like for you, John?
Same here. I think we have a gateway that proxies the request, has all the request IDs on it. We propagate all the request IDs to the upstream services, and that really makes integration a lot more sound. It is it is a backend server, right? There's nothing like that different about it, except for maybe the people that are using it. So we did not attempt to reinvent the wheel. We have been using Apollo platform, and I think we have been hitting the interoperability story is not great. And so I think my dream is you have, your waterfall trace where you have your GraphQL query, those have their request traces that propagate to the upstream services. And you can see it at, different sections of it. But right now it stops at one, you have your Apollo and then you have other traces down here. It's not perfect, and I think there's a lot of improvement to be had there. So I definitely think that investing more in an open standard in the GraphQL server would make that scene a little bit more holistic.
Yeah, I was just bringing this up in the last conversation with John. We're working on this open tracing on like a light specification on top of the open tracing spec for GraphQL, so that it basically fits in with any tool that kind of uses open tracing already. And we're prototyping that with the Husra server itself. But then hopefully that spec is something that people who have open tracing systems can kind of start using, right? And it's really, I mean, all of the scenarios that you can ever imagine with GraphQL are a subset of what open tracing is built to handle. So really just coming up with a good convention of the way that you use open tracing, and actually almost everything should just work together. So yeah, I think that's kind of sorely missing tooling that we ought to have had several years ago. But I think it'll be very helpful. Did you have what about performance and a performance like or monitoring tooling on the client side for GraphQL clients, right? There's quite a few nice kind of like web and mobile kind of SDKs, right? Lots of like different vendor platforms that help you do like mobile analytics and web analytics on the final app that you have. Has that tooling been impacted, or has that tooling changed because of switching over to a GraphQL API, right? In terms of like the data fetch errors that you're looking at, the loading speeds that you're thinking about, like there's quite a lot of instrumentation that comes in with these kind of SDKs, right? So has that happened, or do you have any of that kind of tooling, and how has that been impacted?
That's a good question. I think one of the things that I've been talking a lot about, especially with our backend folks, is that GraphQL has introduced sort of the concept of composition of queries. So I think that's been really interesting to see, hey, yeah, your one part of the API is really, really fast. But because it's used with this other thing that's slow, it's all slow, right? And so the thing is that, but people are like, but that's not my responsibility. But the client is already dealing with it, even in a REST world, even without GraphQL, they have to deal with one slow thing and one fast thing, and it gets kind of like muddled. I think the things that that have been on my mind are Mark mentioned batching, right? Batching, also has downsides because now your fast things are lumped up with your slow things. I haven't found that tooling has changed there, more so than we have been able to expose more succinctly the composition of queries that clients need. And so we can actually better tune APIs to serve our clients rather than kind of guesswork and patching together the API performance from the client side.
Got it. So kind of like if I paraphrase that, is it like saying that because you have a better sense of how those underlying microservices are actually composed in real life, you can focus on performance optimization efforts instead of like saying that I have 10 microservices and all of them need to be optimized. We actually don't care about most of them. We care about microservice number 2, which is always being composed with everything else. And that is slow. So let's all just focus energy there. Is that what you mean, John?
Absolutely. Yeah. Especially when we think about like React server-side rendering, when we have, we do have a waterfall of requests. People will say, hey, this is taking, 30 seconds. Why is this taking so long? And it's
Right.
like, oh yeah, it's not because this last thing was slow. It's because
Right.
there was all this other stuff that was slow ahead of it. And this was just the straw that broke the camel's back. So now we're being a lot more explicit by being able to bundle all of that into a GraphQL query and make it more explicit.
Got it. Got it. Mark, what about you?
Yeah, for us, yeah, kind of that default batching behavior is slow. What we quickly noticed was, well, if you think about a checkout page, it's like user information and yeah, credit cards and stuff. But pulling user information is super fast. It's usually in a cache, doesn't change much. But those cards, again, it's like it runs through all this risk and fraud stuff. It's slow, like it is. And so yeah, we had to separate things into a fast and slow batch manually. In order to have the checkout page load really fast. That manual work isn't fun. Like someone could accidentally add something to the other batch and slow the whole thing down. But you know, we're super excited about the defer directive that's talked about, where you know we can mark those slow fields as deferred.
It makes the manual work a little more bearable, right? Because you're like, I will manually put the defer directive, but that's it, right? I don't have to do anything else.
Yeah, but I think, but even then, it's like, even if we were to have the defer directive, sure, that's great. We could send everything in a single request and get the slow stuff later streamed, but it's still the UI developer's responsibility to know what's slow and to care about it. And I also kind of don't really like that either. Maybe the holy grail would be, you know, your service is aware of calls that are slow and just streams those out kind of later beyond some kind of threshold that you set. Yeah, maybe that would be ideal. Then you don't have to have defer everywhere.
I think that was something that came up too around the defer directive and thinking about if you could do that automatically. So like the VS Code Apollo thing, you know, definitely has a really nice feature where it exposes sort of the P90 execution time for particular resolvers. So, you know, in the demos, it's like, hey, if you call this particular field, it costs, you know, 400 milliseconds. But yeah, of course, you don't know if it's in sequence or in parallel, whatever it is. But I would love to get these automatic tips where it's like, hey, if you defer this field, you know, and then the developer is basically, you know, building their UI resilient, you know, we can type generate all this stuff so that, you know, it can handle being eventually consistent. And you can take these tips, right? They're automatic to make sure that, you know, from a UI developer standpoint, are you getting the most critical data as soon as you can? I would love that.
But it does kind of seem, it's a little bit ironic, right? Because like the whole idea was like, oh, with GraphQL, I can just make like this one query and get everything and not have to care about it versus having different endpoints. And then you're like back to caring about different endpoints, except for the endpoints that are called resolvers now. And now you either have to deal with the fact that like, I'll have each component have a co-located query and I'll make those queries independently so that each component can have its own lifecycle, which is very similar to like maybe kind of going back to REST almost, like each component has its own endpoint. Or if you put all the fragments together and create a gigantic query, then you have to be aware of what is deferrable, what should be deferred or not. And it kind of seems like we're caring about the same problems again, right? So it would definitely be nice to have like some more server-side tooling to, I don't know, take care of this in at least as many scenarios as we could, right? Like maybe, for example, like you have a default cache of your previous data, like a stale while revalidate kind of thing, where you have like I mean, it doesn't work for transactional use cases like Mark said, right? But maybe like if I run a large query, I get the previous cache response as the first load, and then it kind of behaves like a live query where like the slower generated response then kinds of comes into the UI, but like it causes all kinds of issues because your UI might not be geared towards absorbing like streaming data, right? Like it's weird for the user to suddenly see data 1 that automatically switches to data 2. So it's hard, but it would be interesting to kind of have those problems solved at the server. But
I think you make a good point. I mean, the difference though in returning to like the mental model around REST is that, you know, of course, if you do REST really well and you have the right resources, then everything is going to be perfect and it's going to be better than GraphQL. But typically, it's just hard and difficult to build all that out. So in a GraphQL world, what we're saying is that by being able to compose these things in different ways, we're dynamically generating that bespoke payload that you can get. And now you can say, yeah, this checkout component is really, really important. So let's do whatever we need to do, no matter how many resources are underneath it, to get that to load as quickly as possible. Whereas in the other world, again, you're like, okay, my one resource, my one REST thing is loading quickly,
Right.
but
Right.
it's ignoring the fact that it's composed with other things. So I think that's
Correct.
the difference here then compared to REST.
No, that makes a lot of sense. Cool. I think I think those are a lot of the things that I want to discuss. Maybe like, if do you folks have numbers on, or like maybe qualitative or quantitative, like numbers on a before after of GraphQL and the performance impact on your client? Like, do you have like page speeds that have kind of like improved drastically, or payloads that have gone down? Like, what kind of before after numbers do you have on, before GraphQL to today? Mark, John, whatever.
Yeah, I just have one to share. I was talking about it a little bit earlier, but in our guest checkout, which is, if you're like not a PayPal member, there's a lot of like kind of onboarding and user creation steps where there's just a lot of round trips. By reducing those round trips, it was something like 3 to 5 seconds for US users. So it'd be way more for, other users in other regions. But for that use case, it was a huge win. But yeah, anytime you're reducing round trips and doing more work on your server, there's always a win. But yeah, that's one win I could share.
Got it. And what
we've
sorry, go ahead, John.
Oh, go ahead. I'm going on a tangent. Go ahead, Tommy.
Oh, no. I was just asking Mark what those, like, what were the, so what like it went down from like a few seconds to like under a second kind of thing, or what were the
No, it was more like 7 to 9 seconds. Now it's more like 3 to 4.
Okay. That's
a lot quicker, but honestly, it's doing a ton of steps. At least doing 4 or 5 things. Got it.
Yeah, John, sorry, go ahead.
I think one of the things that we've been finding that's been pretty interesting, I don't have the same kind of numbers sort of like drop, I think mostly because we're still using the REST APIs. But I think the composition model has definitely made it a lot simpler to reason about. So in the past, REST resources would have to manage their own calls to other REST resources under the hood. And by having the GraphQL Gateway work as, again, a glorified router, deduplicating a lot of that information relieves some of the responsibility to do that from some of the REST resources. So what you might call a presentational type service doesn't have to do the same kind of legwork anymore. So in our first experiment, basically saw a dramatic reduction in the number of calls to other upstream services because, hey, you don't need that data. We've already fetched it in the context of another thing here. So you can just ignore that call, or you don't even have to go down that path anymore. So we're basically making it easier to build these kind of presentation services that need data from different REST resources.
Right. No, makes sense. Do any of you have any WebSockets or subscriptions in the GraphQL API, or is it all over just like stateless HTTP connections and no WebSocket stuff? Okay, that sounds good.
I think you're the subscription sockets person. So
yep.
I've been doing a tremendous amount of work with subscriptions and WebSockets, so it's been very interesting. There's some really good tooling that we've been able to set up with just kind of looking at like how many concurrent users you have, like what subscription latencies are looking like, and not caring about the stickiness of sessions when it comes to WebSockets and whatnot. So it's been very interesting. I think with defer and stream, it's going to be interesting because some of those concerns are probably going to come in again. I don't know what that is going to be like. I think like a lot of the defer and stream is based on HTTP multipart, but it does also overlap with WebSockets, because you could also just send over the extra data over WebSockets as well. With things like Apollo client, which already kind of just allow you to run queries and mutations on WebSockets instead of running it over HTTP, right? So there's some interesting stuff to unpack there, but yeah, let's kind of see how that works out. Yeah, I think that's it from my side. Do you folks have any questions for each other, for me, or for anything at all?
Looks like we do have one under live comments. There's one question. Looks like it's for John. I'm not sure if we want to answer that.
Oh, sorry. P95 latency, how did we track this? Was this available in Apollo client, or did you check this in a monitoring tool like Prometheus or Datadog? In this case, it was an Apollo report that runs, they have their own sort of tracking and tracing. So it was pretty easy. We get that delivered every morning in our Slack and kind of see how bad of programmers we are.
Which is all that we need to be reminded of every day anyway. So there you go. Awesome. I think that's that, and we can call this a wrap. Thank you so much for being here. But before we go, any picks from you folks about anything at all, especially any interesting quarantine busting tips, or what you've been doing to keep yourself sane during the cabin fever days? Mark, would you like to go first?
Mark, I think you're muted.
Oops. Yeah, no tips for me. I just moved to Chicago a few weeks ago, so I'm trying to explore, but also, social distancing and all that. But yeah, just really exploring Chicago. Love it so far.
That's awesome. John?
For me, it can be really, really easy for work and life to mix together, especially when you're working from home. Please take a break. Please take weekends. I know that weekends mean nothing at this point, but keep them as social constructs. Close your laptop. And I'll put one plug for Tom. I mentioned this earlier. We did GraphQL Ramen last week, and we just basically had ramen over Zoom, and we had a couple Australians there. We had folks from I think someone was on the East Coast. Boston joined in, and then New York as well. We're doing a GraphQL breakfast on May 7th, and that'll be 8 a.m. in the morning to make sure that the Berlin folks can get involved. So stay tuned for that. You can follow me on Twitter, and that's where I'll post more information about it.
That's awesome. GraphQL Ramen is super fun. So if you're around and you see notifications come up, you should definitely pop by for anything John organizes. Super fun, and helps you keep the solitude at bay, excess solitude at bay. What I've been doing is I have a nice home theater set up now. So I have this really good 4K projector that I just clear out a wall, and then weekend movies, or like at least maybe one movie on the weekend. So that feels like you're going to the theater, but like you're just going to a different room. So that works a little bit. But otherwise, thank you so much, folks, John and Mark, for being here. This was really fun. And see you folks online.
Sounds good. Bye.
Bye.